Hi there, welcome to your first Rust content lecture. Today we're going to be setting up our environment and discussing how to get programs running in Rust. Next lecture you'll be with Matt, and he'll be discussing the basics of Rust, variables, data types, functions, comments, all that sort of stuff, just syntax stuff. So without further ado, we'll go ahead and get started. So today's goals is to discuss what is Rust, talk about our dev environment, talk about cargo, and then we'll write a short Hello Rust program. So of course, all of you should already be familiar with Rust. It's the process that happens when metal gets oxidized. So we'll be spending the next weeks in the semester just discussing the different patterns that arise, different types of metals and how they rust, and all that sort of fun stuff. My personal favorite is the center image in the top. I think it's kind of got a nice pattern on the ring, but I'd love to hear which one your favorite is. Other than that, Rust is also a multi-paradigm system programming language. If you don't think my puns are funny, then I apologize, and I'm so sorry for the rest of the semester. But let's break down what this means. So multi-paradigm. Programming paradigms are different functions or different ways that different languages can be used for. So we look at a language like Java, C, C++. A lot of these are what we call object-oriented programming languages, though some of them are also multi-paradigm. Most of the very popular languages are multi-paradigm. Though when we look at other languages such as Haskell, we know that that's a functional programming language, and that's what we call the functional paradigm. So Rust allows for both object-oriented functional paradigms as well as other paradigms that are less popular. And in fact, we'll learn a lot of these. We'll learn both object-oriented programming in Rust for most of the semester. And then in the last 2 weeks, we'll also talk about functional programming in Rust, which will be interesting. And then system programming language. Well, system programming languages are programming languages that are used for systems. And more specifically, system programming languages are designed to provide easy access to underlying hardware, and they often optimize for performance. An example of a system programming language is something like C or C++, where you can very easily allocate new memory, deallocate memory, and sometimes do things that can cause some trouble, right? If you leak memory or have pointers pointing to nothing or lose pointers, all that sort of stuff. So Rust, on the other hand, focuses on memory safety. So it has all of these things, but it focuses on memory safety and tries to prevent you from even being able to, we'll say, lose memory or have memory leaks. And because of its memory safety, it also allows for very easy concurrency. And so you can very easily build your programs to be able to be run on multiple threads at the same time without causing any issues. And we'll talk about this later in the semester. We'll focus a lot on program concurrency and why it's important. But the short answer is, concurrency is going to allow multiple processes to work on the same task at once, and your applications can become much more efficient than possible otherwise. Syntactically, Rust is the most similar to C++. So if any of you are coming from a background in C or C++, you'll see some similarities there. But of course, it's not too different from most other languages. Really, the difficulty in learning a new language is not in the syntax. It's actually knowing what to do from a programming standpoint. And then from those who actually use Rust, Rust has been voted the most loved programming language for I think about 5 years straight now. Something about 80% of people who code in Rust say that it's like their favorite language. And there's a lot of reasons for this. Some of the most kind of important reasons is that just because Rust is such a new language, there's a ton of really great features that make your life easy. Excuse me. Specifically, we'll talk about Rust's error messages a lot and how incredibly helpful they are. They tell you, of course, not only the line that your error is occurring on, they'll tell you what the error is, they can tell you how to fix the error, they can tell you the specific place in the line to fix the error, and even very often there's some tools in Rust, or at least Cargo has some tools, and we'll talk about what Cargo is in a bit, called Cargo Fix, that allows it just to go and fix a lot of these smaller bugs for you. So you don't even have to do anything, just say, I believe that you'll know what to do, and it'll fix a lot of these smaller things. Of course, larger bugs, bugs in how you implemented it might not always be caught, but they will be caught much more often than something that isn't doing these checks. So let's talk a little bit more about Rust. all of the Rust files that you're coding in are going to end with .rs. Of course, that's going to mean it's got Rust code inside of it and it's executable, etc., etc. Rust files do need to be compiled before being executed, and we do this with Rust's built-in build system / package manager that we call cargo. Of course, build system represents that it's going to be doing the compiling and building of your project, while the package manager means cargo is also going to allow you to install other packages, other people's code that allow you to just accelerate your development. And in fact, when you're doing the final projects much later in the semester, we're really going to encourage you to use external packages to do something really great. Being able or having to write every single line of code yourself, especially for really, really complex features, can sometimes be, prohibitively difficult. And so, there's hundreds of thousands of cargo, or I should say Rust packages out there that allow you to do, anything you imagine, right? It's just like Python or C or C++ in that, you can rely on other people's code in order to accelerate your own development, especially with these personal projects. Okay, so let's talk a moment about your development environment. At this point, you should have your CS128 environment running. I'll give you all just a short moment to pull that up on your own machines. You can see I have mine here on my machine. I have it open in my terminal so that it's a little bit easier to read with the black and white background. I believe the font will be big enough to read, but if it isn't, let me know and I can increase it in future lesson videos. All I've done here is CD'd into my source directory. And I have nothing else in here, or no files, no folders, it's just this. I believe you all probably have your Hello World from your main 128 project in here right now, or lesson MP. That's fine, no worries there, just leave it. But I don't have anything for my demo, so. Okay. So hopefully by now you all have pulled up your environment. If you haven't, I encourage you to do so and to follow along. While it's not completely necessary, it will just make sure everything's working. And eventually, once we're working on the MPs, and especially your homeworks, it'll be quite helpful to have a local development running, or at least in your VM, have a development environment running. Okay, so let's talk about cargo basics. Here's a little logo I found, Rust Cargo. I just thought it was nice, so I included it. First, let's make sure cargo is installed. This is pretty easy. You can just do cargo version, check what version we have. Since this was pre-installed on your virtual environment, you should have cargo 1.53.0. If you don't have this, then let me know. Or if you don't have cargo, then let me know. But you probably, if you don't have cargo and you're in your virtual environment, it's possible that you have set up your virtual environment incorrectly, but I think that would be a very rare case that you're SSH'd into your virtual environment, yet you do not have cargo. So hopefully you should all have this. I went through the same setup instructions as you, and so you should all have cargo. And let's make a new project. So for this, we'll do cargo new hello Rust. We'll let this run for a moment, and we can see that it's created a new application or a new package for us. We'll see what we have, and now we have this hello Rust folder. So let's CD into that. Okay, scoot this over. So when we ls here, we see two things. First, the source folder, which we can see on the slide to the right, and then also the cargo.toml file. First, let's explore what this cargo.toml file is. So I'll use Vim to edit this file just to view it. I know some of you might be using VS Code. Some of you might want to use, Nano or Emacs. All of these are totally fine. I'll just be using this so that we can very easily kind of view it and edit it, and also it's what I know. Okay, so I'll open it up here, and we can see that this is what we call the manifest for the project. So it contains information for the project that we're writing. Of course, the name of our project is Hello Rust. This is version 0.1.0. The edition is just 2018 as the default, and all of this is kind of normal. We don't have any dependencies because we haven't installed any other packages, so that's expected. There's a lot of other things that can go inside this cargo.toml folder or file, and I encourage you, if you're interested, to look into some of it. Maybe some of it will come up when you're doing your final projects, and you might have to edit things in there, but for now, we don't really have to worry about it. So instead, we'll move into the source directory, and we see in here that there's this main.rs file. Once again, we'll view this. And we can see a short 3-line program. Function main, left parenthesis, right parenthesis, open bracket, close bracket down here, println hello world. Hopefully you can all kind of figure out what this is doing. Hopefully it's not too surprising that this is going to print hello world. So let's just very briefly edit this. Again, I encourage you to do this on your own machine. We'll just change hello world to say hello Rust. And we'll save and exit that file. Just to make sure that, just to show you that I've edited it, we'll hop back in just for a moment, and then we'll move back to the root directory for this project, hello Rust. Okay. Did I change the name of cargo.toml, I wonder? No, it was just scooted over. That was fine. Okay. So now what? We've changed that file, but we clearly haven't run anything. And so we need to, of course, compile our Rust program before we're able to run it. And so we're going to learn some useful cargo commands right now. First, we'll learn cargo check. What cargo check does is it uses the main.rs entry point, and it just goes through and it checks all your code for any issues. Of course, our code is very basic, and so we don't have any issues, but how about we hop in there and I'll introduce an issue. So you don't have to follow along for this part if you don't want to, but I'll hop in here and I'll say let x equal 5, and then we'll change x to equal 6, okay? And of course, to some of you who are less familiar with Rust, that might not seem like it has any issues, yet when we run cargo check, we can see that we get this error, cannot assign twice to the immutable variable x, cannot assign twice to the immutable variable x. And something that's kind of handy, we very briefly mentioned Rust's error messages. It says, hey, this is your first assignment to x, consider making this binding mutable. So it says, hey, you should change let x equal 5 to let mut x equal 5, or mutable x equal 5. And we'll learn more about what this means later, but sure enough, just to show you how useful these errors are, I'll do that, and I'll run cargo check again, and we can see that we're totally fine. Now, we do still get a warning, we change x and we assign x, but we never actually use it. And so it's like, hey, why are you actually doing this? It's kind of useless. So value x is assigned, but never read. Value x is assigned to, but never used. So totally fine, just warnings, nothing too crazy there. If we do want to get rid of those, maybe we add like a print statement or something down below, but I don't really care. So we'll just delete these lines. Oops. Great, okay. Wonderful. Okay, sorry for that jump cut, but let's get back to it. So now let's look at cargo build. So we've looked at cargo check. We know that our program is, passing all tests. And now we can do cargo build. And so it'll take a second. It'll start with that main.rs file. And what's it going to do is it's going to convert the Rust code into an actual executable for our program. Now this executable is stored in target debug. Whoops. And then in here, we can see hello Rust is this file here that we can sort of directly execute. So in fact, I can simply just say .hello Rust, and it'll run, and we can see it says hello Rust. Of course, we can go back and we can change it to say something else. So I'll hop back into source, I'll change main.rs, and I'll say hello, whoops, hello CS128 honors. And we'll save. Of course, if we run this right now, so if I run target debug hello Rust, it's still going to say hello Rust because we haven't rebuilt it. And so for this, we can say cargo clean, and this will clean all the files, and then we can run cargo build again. You can also just run cargo build, but I really encourage you to run cargo clean first. And I'm pretty sure if you have a build already there and you run cargo build, it's potentially going to automatically run that just because it's so important too. Great, so now when we run this file, once again, target debug hello Rust, we can see now that it says hello CS128 honors. Now finally, there's one more command, cargo run, which just does all of this for you. So it's going to compile it, it's going to build it, and it'll run it for you. So kind of helpful there. We could say cargo clean, cargo run, compiling, building, running. And we can see it prints it here. So very useful stuff there. I encourage you all to keep these in mind when you're doing your own. Okay, let's briefly talk about two little extra fun cargo commands that I think are interesting and fun to talk about. And these two are cargo fix and cargo bench. Of course, there's a ton of cargo commands, so if you're interested, I encourage you to look at some. And once we get into package managing, we'll look at a lot more that have to do with importing, downloading, managing all of these packages. But let's look at these two for now. So first, let's look at cargo fix. I briefly mentioned this earlier in the lesson. There's a command in Rust that allows it to sort of automatically fix these bugs for you, and so we'll look at that now. We'll head into our source main.rs file, and we'll once again change this x to be let x equal 5, x equals 6. So again, when we run cargo check, we'll receive an error saying, hey, this variable is not mutable. You can't change the value since you're trying to assign it twice to an immutable variable. Now, of course, we'd never be able to run cargo build or cargo run, but just for the sake of trying, I'll give it a shot. It errors out and nothing works, which is sad because when programs don't work, I get sad. So instead of doing this, we can run cargo fix. Now, directly, cargo fix won't really do anything, but what we will give it is we'll say, hey, my code is broken. I want you to fix it. So we'll give it the broken code flag. Now, there's a ton of other flags. There's stuff like addition. There's stuff like allow dirty code, allow staged code, tons of different stuff. So if any of you are interested, I encourage you to look at some of these in the Rust docs. But for now, we'll just run Rust cargo fix broken code. So it'll take a moment, and let's look at what it did. First, it checked our code, and then it fixed our code. And so we can see the warnings here after it had fixed it. If you remember very briefly, I had removed this mutable variable. Of course, there's still a warning because we never actually used the variable. But when we edit this file once again, we can see that it directly inserted this mutable keyword in order to fix the error. And once again, just to show you that it works, I'll remove it, view it, we'll run cargo fix again, and we can once again see that it had fixed our error. And once we run cargo run now, we can see we still get the warnings, of course, but we still get hello CS128 honors. So just a fun little tool there. Sometimes it can save you a little bit of time. Of course, you have to be a little bit careful. It's going to fix whatever it thinks is right, but sometimes the issue is different, right? It might fix, maybe this int needs to be immutable, and making it mutable actually crashes some other part of my program when I expect some parallelism and concurrency to go on with it. Okay, next is cargo bench. This one I can't quite give an example for. It's a little bit more involved, but it allows you to write some tests and then benchmark these tests. I think just cargo bench is a really great example of kind of the heart of Rust, right? It's this system programming language, focuses a lot on concurrency, writing efficient code, writing smart code that, is managing your memory and memory safety very well. And it even has a built-in tool that allows you to kind of test how efficient your code is in a very easy way. And, stuff like cargo bench is also, something that we would love to see when it comes to doing your final projects, right? If you're benchmarking your code and showing us, proving us that, hey, we tried this function, then we tried this function, and this one was much faster, or this implementation of it was much faster. I think that's just something that's really awesome to see and probably deserves a lot of extra credit. So, just fun stuff like that show sort of the heart of Rust and the heart of cargo and what we really like to see. Okay, so some final course announcements. Now that you're at the end of the lecture, we're still setting the PrairieLearn up. We've run into some technical difficulties, but any due dates that might get pushed back, or any due dates that might be affected will get pushed back. You will have a short quiz this week on PrairieLearn, just introducing basic Rust concepts, creating variables, assigning variables, changing variables, comments, stuff like that. Nothing too crazy. Should take you probably no longer than 15 minutes, 20 minutes, something like that. Once again, if you're enrolled, try to make sure you're in the Discord. It's not, critically important, but it is going to be one of the major ways I communicate with you. It should be in your email. You can also email me at woostis2 if you haven't received that email, which is probably likely the case if you enrolled in the class a little bit late. I believe the information for the Discord should also be on the YouTube channel. This is posted in one of the previous videos. But if it isn't, just email me. It's no trouble. woostis2@illinois.edu. Okay, I'll see you all, or rather, you'll see Matt next lecture. He'll be talking about Rust basics, ints, comments, types, instantiating variables, mutability maybe a little bit, all of that sort of basic stuff. Congrats on your first lesson, and I hope you have a wonderful rest of your week.